Hello everyone. Today we're going to ask ChatGPT to give us a problem that may help me prepare for IOI. So let's see. What can I say? Yeah. Give me a programming problem that will prepare me for IOI. I think. Yeah.
Beginner program?
Yeah. Uh, Beginner. I forgot the spelling. I think this is correct. Yeah, I think so. Hmm. ChatGPT. No, okay, that was strange. So give me
Refresh this once.
one.
Maybe some definition issues.
Could be, yeah. We have to stop refreshing. That's the thing.
What happened?
I don't know. I could stop it and maybe just try it again.
Yeah, just search for test in new tab. That is working.
It's working, okay.
This is more about
ChatGPT. Wait, stop loading.
Shift F5, style, hard load.
Yeah, I think that worked. Yep.
What is the new chat? Already there?
Yes. When we type, it will just give us a new chat for us.
Okay.
So let's see. Give me a beginner, I think, beginner programming problem that will prepare me.
That will help prepare.
Yeah, it will help prepare me in
For I think it may not like I will have many various meanings. For Olympiad in Informatics. Olympiad. O-L-Y.
L-Y, huh?
M. O-L-Y-M-P-A-D. In Informatics.
Informatics.
Informatics. Informatics. I-N-F-O-R. I-N-F-O-R.
I-N-F-O-R.
I-N-F-O-R.
O-R.
Informatics.
Yep, no, he's not listening. Or it is not listening.
Not listening.
Maybe we need to update this.
No.
Update, but yeah.
Just say hi. I don't know.
Hi. Nope. Hello. Yeah, it says ChatGPT can make mistakes. Okay.
But we are not like this.
Not cool.
Show me a code snippet.
Nope.
Nothing is working. Why?
Oh, wow.
Now it is. And now maybe
Okay.
it started working.
Maybe just need a little boot, I guess.
And now see if this works.
Again?
Maybe you can just this time copy the question that you want.
True. Beginner programming. Whoa. Okay. Problem that will help me prepare in
For the IOI.
for
The Olympiad.
all index. Okay, fine.
What?
I selected it, I copied it, then I pressed enter. So this whole thing got replaced with enter. Yeah, I don't know how how JavaScript and all that works. Yep, no, still not listening. Boom.
Yeah,
Not-
finally it booted
Ah,
up. It looks like.
but now he's thinking. It's thinking.
Yeah.
Not it, but it.
Finally you got something.
Ah, at last. Okay. Really? Okay, certainly.
And now it is doing
Why
it
is
again and again.
twice?
Two of it.
Some multiples. What?
Okay, go back up and see. Okay, it's bigger 11.
Maybe it's like, oh, he's giving us two responses at one time.
Okay.
Okay, that's interesting. So, given a non-negative integer n, the task is to calculate the sum of its digits. For example, if n is 1, 2, 3, the sum of the digits will be 6. So yeah, okay. So it requires an int, not a string. So that's really irritating. But I think that's fine. Okay. So let's go to VS Code now. Yep, here. So it says, let's call it chat. I don't know. It's a prefix, and we'll call it sum of digits dot cpp. Yeah, okay. So we'll need to take the number, yeah, and maybe we'll require the string version as well. Maybe not necessary, but okay, let's do it this way, the sort of easier way. So you want some integer n, I'll give you that, like so, and then we could have a string and we could name it stir n, I don't know, and it is equal to a to I, no, not e to I, which one will it be? Not a to I to a, yeah, I to R, okay, and you want the value n. You're good with this? No, he's not happy with this. Why? Because too few arguments. Okay, why?
You can also use
Because
two string.
two string.
Yeah, std two string.
Oh, this all this thing. Std two string.
Two
Yeah,
underscore string.
for n. Okay, good. Now if you go in string n. Now we'll say for auto n in stir n, or maybe I or C.
We have kept it small, the n.
Hmm?
We aren't using capitals, so you should have kept it.
Well, this is the input is n. So yeah, I think we can change this to n.
But even that should be small.
Okay. Yeah, I could have just done. Yeah, I could have just done the replace option. Okay. Okay. Yes. So we got the character now. And see, so if I have a, so I think how's the ASCII table like? Because there now we can use the ASCII table to figure out what number that we to actually add to the sum of the digits. So ASCII table. So it's like 1, 2, if it's zero, it starts from 0, it starts from 1.
Okay. So what do you want to add?
It will just like,
What is the problem?
this is ASCII table of
What is the problem? Exact problem?
sum of digits of some given number.
Okay.
Oh yeah, it's here. Okay. Maybe let's see. Okay, whatever.
You can go to image.
Yeah, that's what I clicked.
It's so slow.
I know, it's very slow. Quickly. So yeah, finally it's ever so slowly coming here. At
But do you even
last.
need that? Why
I
do
do
you
know
like-
because I don't know if the ASCII table starts like the number series start with 1 or 0. That is necessary, right? This will also take some time, obvious. I can't just sneak it from here or something. Sneak. Yeah, it starts from 0. Okay, good. So it starts from 0. So whatever number I get, like whatever character I get, so if I have character 1, I want 1. And what is that for? Like, I just, yeah, it's easy. So we have to take C. So yeah, we'll have a int sum is equal to 0. And we'll say that sum plus equal this expression. So we have to do the character and then minus the ASCII value of 0. So if it's 0, it will have a value of 0 because the distance between the two is 0. But therefore 1, it will have 1. 2 will have 2, and so on. We'll add that much to the sum, and that's it. We'll say std cout. We'll say sum of digits of n is sum. Sum. Done. So return 0. Just really quickly. Yeah. At last. Good. Now where should I run it?
You can test it first.
Means?
Yeah,
Where?
test it. Yeah. In Ubuntu.
Yeah, it's here. Okay, yeah. So g plus minus o. Okay, sum of digits. So chat. Sum of digits for chat. Yeah. You say dot slash chat. Yeah. Let's give it 1, 2, 3 first. 6. 1, 3, 5 is 9, which is correct. Yeah. And we have 1, 8, 0, 0, 5, 7. I think I can't be fit inside this thing. Okay. It will 21. Why? Because this will be 6. So like, yeah, 21. Yes, correct. And now 5, 5, 6, 5. Yeah, that's also 21. Okay, good. It's working.
Good.
Yay. Okay. So I guess we can just copy
It
this.
says 5 of 5. Okay, what is it? 5 of 5 over there. At the very top.
Yeah, I think like different ways of doing it. Others they're like multiple.
Okay.
Well, I think this is giving you multiple responses. I think.
For the same query.
Yeah, same query. Yes. Okay, what's this? Problem, sum of multiples. Okay. You're given an integer n. Your task is to find the sum of all the multiples of 3 or 5 below n. Okay. So if I have 10, so the multiples of 3 or 5 below 10 is 3, 5, 6, 9. So it's not including 10. Okay, so it needs to be strictly below 10. Okay, interesting. Some of these numbers are these. Okay, I think that's easy, I guess. So how would I do this? So because they're numbers that are multiples of 3 and 5, and that could be a bit of a problem. So
3 or 5.
3 and 5 and 5. Yeah, the 3 or 5, but that, like I was thinking we can just add like in steps of 3
Okay.
and then steps of 5, but we're going to have duplicates.
Okay.
So how can I calculate those duplicates? That is the problem. I think it's easy, maybe. Like maybe we just need to find how many 15s fit inside the number, and then yeah.
Think about it. Yeah.
Right, because we have to see how many 15s fit inside that number, and then it will cross out 15, 30, 45, like those numbers simply. So yeah, that's easy. Maybe, I don't know. Let's see. Let's say chat multiple of sums. What? Sum of multiples. Yeah. Come back. Yeah. Okay. Sum of multiples. CPP. Yeah. So oh, yeah, we can also say that like, well, no, we need to. Okay, wait. Yeah. So let's see. So we just need this, then int main void. So we need an integer and we'll get the n. Why not? Done. So first one way is to just like mm,
Small n.
small. That's one. Okay, so we could count how many three multiples of 3 fit inside the number, right? Okay, so otherwise we can simply just do this. Let's go very simple. First we'll say for int n is equal to 1, not 1, but I think that's like they're not allowing 0 or something. No, they're not allowing 0. So where is it? Yeah, okay. So yeah, so we'll start at 3 and we're going to say n should be less than equal, not n, wait, maybe num, I guess is 3. Num should be less than equal to n and plus num. So what will we do? We'll just say if num percent 3 is equal to 0, so it's a multiple of 3, then we say that we'll just say the count is not count, so we have to add that number to say int sum of multiples again, multiples is equal to 0. So num percent 3 is equal to 0, it's a multiple of 3. That means sum of multiples plus equal that num. That's it. And yeah, and then that's then done. So we'll say else if num percent 5 is equal to 0, so it's a multiple of 5. Then we say sum multiples plus equal num. And there's repetition there, but it's not going to do both because it's going to check this, make it like have it true. If like it's 15, this will work, it will come here and it will not do the else part, so it will not count any multiples of 15 because duplicates of 15. Yeah,
Nice.
that's good.
I was thinking like maybe we can do if num percent 3 is equal to 0 and num percent 5 is not equal to 0, then do it in one go and then do another loop for 5. This is better, right?
Yeah, and we don't want to go to n, as they said, we don't want n. We'll also remove that. Will this be stored in an int? I don't think so, because now what is the limit? Okay, 10 to the 6th. That will be quite big. I think all the multiples of 3s and 5s and all that. So maybe we can just make this long, maybe, I don't know. Maybe that's not enough, but okay. After that we'll say return, not return, yeah, we'll just return 0 for now. And we'll say the sum of the multiples of 3 and 5 below.
I think it's confusing. Sum of the multiples of 3
and 5
and 5. So it's like multiples of 3 and 5. Yeah, I think it's.
right. Well, 3 and 5, then we have to say like multiples of 15.
It is doing union kind of.
Yeah. Multiples of 3
Sum of the multiples of 3
and the multiples of 5. Yeah.
The sum of the multiples of 3 and the sum of the multiples of 5.
Why?
Right?
Yeah, we could say that. Yeah.
Sum of both.
Yeah.
Sum of sums. But yeah. Let's not make it complicated.
So the sum of the multiples of 3 and the multiples of 5 below n is sum of multiples. And okay, done. Good.
So what's the complexity for this?
Just n, like this.
Can we improve this?
N minus 4, that's the complexity.
Yeah, but can we improve this?
Can we improve this? Yes.
Why?
Like just constant time, I guess.
How? Constant time?
Yeah.
How?
Me, I don't know. Like, so basically, we can see how many 3's are in, not 3's, yeah. How many 3's are there in that number? How many multiples of 3 are below that number?
And then just simply multiply that.
Yeah, like we'll just take 3 and then, so basically it's like 3 plus 3 plus 3, which is 6, plus 3 plus 3 plus 3, plus 3 plus 3 plus 3 plus 3, right? Because we go in multiples of 3, right? So if we have like say 15,
right,
we're going to have 1 3 and then plus 2 3's plus 3 3's and then 4 3's. It is somehow figured out not how to not include the fifth 3, like the 5 3's, because 15 is a multiple of 3, but we cannot allow 15.
Good thinking. Yeah.
And same for 5.
So how do we, like, what is the formula for adding like 3 and then 6 and then 9?
Like just, yeah, that's easy, right?
What do we do for that?
So whatever is the biggest multiple, we divide it by 3. And that is how many 3's are inside that number, right? So you can take the arithmetic progression of that.
How to do that? So 1 plus 2 plus 3 plus 4, what is the formula for that?
That is highest number into multiplied by highest number plus 1 and all that by 2.
N into n minus 1 or n plus 1?
Nothing saying plus 1.
N into n plus 1 by 2. So
yeah.
That is your count of 3's. And then multiply that number by 3.
Yeah.
Correct?
Yes. But someone to exclude the 15's and 30's and 45's as well.
You to exclude.
Like, since we're also going to do that for 5, then we duplicate 15's and 30's and 45's.
Then we can do one thing.
What?
We can add it for 3, like with the formula as you said.
Yeah.
We can add it for 5, and then we can exclude the 15's multiples of 15.
Yeah. Yes.
Only?
Correct. Yes. Because
Correct?
yeah.
Will it be exhaustive?
Sort.
Okay. Yeah.
Yeah.
So, but yeah, let's
First, let's get this running.
run this and
so, what is it? Yeah. So G++ minus O chat really chat sum of chat sum of some, okay, sum of multiples chat m, yeah, okay, but okay, yeah. So then will give us 23, right? Yes. 3 5 6 9, correct. And wait, is it, yeah, let's do it for 15. So it's 45. Okay, that's interesting. So 3 plus, yeah, it's like 3 plus 9 plus 9, 3 plus 6 plus 9 plus 12, not 15. So yeah, that's one thing. Okay. So now for this, right? Let's see. So I can make a new file, maybe. Let's make a new file.
yeah, you can then name this as version F2 as version 1.
And we'll just keep it like this. Create a better version. Sum of multiples v2.cp. Okay. So I think we just copy it, I guess. So we got n, then we don't want these things. Yeah, not this. So if we have got n, right? So how we will do this? So like first of all we'll get multiples of 3 first. We'll get rid of that first. So basically to find how many 3's are there in one number, basically we'll take the remainder, subtract that from the original number, and then divide by 3. So we know how many 3's are.
So if I give 100,
Yeah,
then how many 3's are there?
33, because 99 is the
33 3's are.
yeah 33 3's are 99.
There are 33 3's
In 100 plus one extra.
Was that, is that what we want?
Yeah, we want 33.
So where does the n into plus 1 by 2 kick in?
That is, we have to first figure out how many 3's we have.
Okay.
Multiples of 3 we have.
Okay.
Basically, we have to see, we will say int, maybe int. Okay, that's fine, I don't know. We'll say int number of, oh yeah, I will just name it something. Multiple of 3 count, I guess, is equal to, so we take n, like we take its remainder first, right, and we'll subtract that from n, and that, now we're ensuring that is a multiple of 3, and we'll divide it by 3. Now it will work, but I think that's not necessary, right?
Yeah,
We can just simply divide. Yeah, so just okay, yeah, I figured out how integer division works. Yeah,
Multiple of 3 count. Multiple of 3 count. Okay. What do you mean by that?
multiple of 3 is count.
Okay.
That's it.
So you get 33. How does that help us?
So we got 3, and then we got 3 plus 3, and then we got 3 plus 3 plus 3, and that goes till 11 3's. So you do the AP or the arithmetic progression of 11, and that will give you how many 3's we have.
Okay. Okay, so you are going to do now AP of 33.
Yeah, AP of multiple of 3
AP of
count.
33 multiplied by 3.
No, not 33. 11. No. Yeah, 33. Sorry, 33. Yeah. Sorry, yeah. So now we'll say that our sum of multiples is equal what? So n, not the n, but is equal n into n
Small
plus
n?
1. No, I'm just writing the formula first. Yeah. Then I'll substitute this for n, the variable. Really? Okay. Yes. So this is how you actually write it. Then I have to take this in place of n. That's it. So AP of this, of multiple of 3 count, and from that take the AP of that, and we have to multiply that by 3. So we'll get 3 plus 2 3's plus 3 3's plus 4 3's all the way to adding 11 3's.
Okay.
Done. And also one more thing, that if n percent 3 is equal to 0, then we'll do sum minus equal n, because we're not including n, that's why. So we want to include, if it's 15, if you got n equal 15, we don't want to include the 15 as well, right? But it will include that in 15. Got it, right? So if I have n equal 15, it will do n by 3, which is 5, It will do AP of 5, which we don't want. We don't want to add 15 as well, we just want to add till 12, not till 15.
Okay.
So if n is a multiple of 3, sum of multiples will subtract n. Others will not subtract n.
Okay.
Because it's not a multiple. Done. Yeah, cool.
Same for you.
Do for 3, yeah.
5.
5, yeah, not 3. Simply, not simply, but okay, still. 5 and 5, and then AP of 5, number of 5s, and multiply by 5, and if it's equal to 5, we'll subtract that. I mean, maybe I have to change this if, but yeah, I don't know.
What next?
There to fix this multiple of 5 count thing, because now we're also including multiples of 15 twice, which is not good.
Okay.
How are we going to do this? So we got all the multiples of 3 added together except the n itself, if it's a multiple of 3, and all the multiples of 5, but some of them are overlapping. So we need to remove the number of 15s that is inside it.
Because they appeared twice.
Yeah.
So to remove them twice or only once?
Once. Because one number will take that multiple of 15. 3 will take the 15 or something like. We don't want the 5 to once again repeat 15. So we only need to remove once.
Okay.
So we need to find the number of 15s inside it, and that's it. Not that's it. Maybe now what if our n is a multiple of 50, right?
So why are we like bringing n here? We can just do it for n minus 1 always. We can just decrement the n, and then instead of working it like that every time, like worrying about okay we want to go below n, we can just simply say okay we never took n, we just took n minus 1 as our input and calculate.
But we can't always do that, no? If it's a multiple of 3, then we have to do subtract 1, right?
So what I meant to say.
Yeah, yes, I got that.
Right.
You can do it like that. Instead of having a multiple of 3 or 5, we can just reduce it by 1 and it will work.
Okay. Yeah, whatever suits better.
So we have this. So if I have 15, from both 3 and 5 I removed 15. So it's not included. So how does that help us? So to add a 15 again if it's a multiple of 15. Right, if n is a multiple of 15, we have to add back the 15.
I'm just thinking, is it not simpler to simply just subtract 1 at the beginning and then calculate normally?
We could.
Is it better? Like we don't have to worry about anything, all of this thing. It just works. I'm just saying, I don't know.
Yeah.
I'm not very sure.
Yeah, it will work.
So what do you have to remove from there then?
We can remove the ifs and you can club them into just one if. If it's a multiple of 3 or the multiple of 5, then reduce it by 1.
Reduce it by 1?
Yeah. So it is not a multiple
no,
of 3.
but are you working with
not
n minus 1?
Now we'll work for it. We can do that. It's better.
Okay, so how does the report change when you do it for n minus 1?
So this if and these two ifs will not be there anymore. We can just say
minus n.
No, not minus n.
Initially, just start at the very start, just do minus n, decrement it by.
No, what if it's like one more than a multiple of 3? Then it will go back to a multiple of 3.
Which is okay, right?
No, that's not okay. Because we don't want. No. That is okay, yeah. Because we can include that number because it is strictly below n, right? That multiple of 3. So yeah, we can just subtract. Simple. So subtract n.
You can comment like this, kind of a bit more subtle. Not so obvious.
Avoiding multiple of 3 or 5. For now.
Multiple of 3 or 5.
Something, right? So look like this, which is better, yeah. And then find the number of 15s, subtract that much, yeah. So int multiple of 15 count is equal to n by 15, and then add ap of 15. Well, no, not add, we have to subtract. So subtract once, subtract not once, like all of them, all the duplicates. So yeah, ap of 15 multiplied by 15, yeah.
That you subtract.
Yeah.
Once.
Yeah, just once, not twice.
Now, is it correct or you want to verify this?
But to work, right, because n will be not a multiple of 3. All the numbers that are multiples of 3 and multiples of 5 now will only be selected, like will be strictly below n, right? All the multiples of 3 that are multiples of 5 that we are selecting. So we are going to find the number of the multiples of 3, number of multiples of 3, and since 3 is just 1 times 3, and then 6 will have 2 times 3, 9 will have 3 times 3, 4 times 3, 5 times, like it will go like that, right? So to do the AP of the number of 3's inside n, and from that we can.
Okay.
Same for 5, and since some numbers like 3 and 5, like 50, multiples of 50, which is 3 times 5, can also like will emerge like double times. We have to take the multiples of 15 and subtract that, so we don't get the duplicate 5 times 3 and 3 times 5, something.
Okay. Okay, so
Simple.
we can try this.
And then
is there something like division by 0 or some other weird errors or some edge cases that you have to worry about?
No.
Like what is
Yeah,
the
this will become 0, like 1 by 3 or 2 by 3 will be 0, so there's 0 zeros.
Okay.
And then 0, and then -1. Okay, this
What is
is
the negative one?
yeah, like 0 multiplied by -1, all that by 2, but that is just 0 by 2, which is 0 still. That works. You can do 0 by 2, it's fine. So yeah, we can do it like this. Let's quickly just do this. Where is it? Yeah. So g plus plus minus o chat sum v2 and chat of multiples of map dot cpp, yeah. So dot slash some multiples v2. So 10, it gives us 9.
Which is
Incorrect.
Incorrect.
First of all, it's printing now this.
Oh, that's
Printing it wrong.
This is bad. Numbers one.
I say 50. Now it is showing 23. Interesting. Okay.
Let's debug this. Yeah.
So yeah, we could debug this later. We'll do this later now. Like yeah.
Yeah, you have some time. We could.
Yeah. So let's see how we went. Where we went wrong. When we have 10, right? So it went to 10. It became a 9, and we said 9 divided by 3 is 3. So we have 3 plus 3 plus 3 plus 3 plus 3 plus 3. Right.
Sorry, what you should
Got it. Yeah. Why do we have a -1 here? We need a +1.
Oh.
Simple. So that's it.
And that n should be n plus 1. Line number 23.
But not this. This. 3 plus plus. And now let's say 10. And now it's 23. And if I do 50, it will show 45, which is also correct.
Good.
Wow, nice. So we just made it like constant time, literally.
So for a big input, we'll run fast.
Yeah, like too fast. Like,
Cool.
yeah.
Good. So I think you're good for today.
Yep, sure. Yes. Bye everyone. See you in the next session.
Okay.